Okay, we're hopefully going to finish up this geometry section. So let me turn that on right there. And here we go. So I call it R3 for review, and then part 2. All right. Well, I actually did a little bit of work, and I got these pretty pictures. I'm going to put this on here. Isn't that fancy? All right. So they basically call this a rectangular box, all right, is what we're going to call it. So let's write that down. So rectangular box. Okay, so it's a rectangle. You look at it and you say, it's a square, it's a cube, whatever. Okay, you can call it a cube, but I think a cube, all the sides are equal to each other. This is not necessarily all the sides are equal to each other, but it's a three-dimensional rectangle, basically, is what it is. All right, and so what we're going to do is we're going to look at a few of these. Let's call one of the sides the length. We'll call one of the sides the width. And now, what's the other side? I got this, the height. Okay, it could be either this one, it could be this one, or this one. It's the same thing. I'll just put it right here. You see where the height is? It's from this point right here to this point down there. So that's the height. All right. Now, it doesn't really matter which one you call what, but that's what I'm going to call them right there. So we got a couple formulas for it. First one is the volume. So we haven't talked about volume before. The volume is how much stuff you could put in here. Basically, how many 1 by 1 by 1 cubes can you fit inside of this box? That's what you're asking for the volume. So volume is all the stuff that fits inside of this box. All right, basically. It's not exactly true, but it's basically how you want to think of it. And it's very, very simple. Okay, it's just the length. I'm going to put dots instead of X's. The length, it's an ugly dot. Let's try it again. Length times the width times the height. That's very simple. All right, so if I want to find the volume of this, it's the length times the width times the height. Now, let's talk about the units. And I should have talked about this yesterday. I didn't, but I should have talked about this. Let's talk about the units of this. So let's say we measure this thing in centimeters. All right, so we measure this as whatever centimeters, centimeters, centimeters. All right, so this is in centimeters. My dots are hard to make with this pen. That's in centimeters, and this is in centimeters. So if I multiply all those three together, what's my unit? For instance, let's say this was 3 centimeters, this was 4 centimeters, and this is 5 centimeters. We'll just make it kind of easy. All right, sorry, it looks a little ugly right here, but that's what I had to squeeze them in. So if we wanted to find the volume of this, and this was 3, this was 4, and this was 5. Okay, that's our situation. And it said, what is the volume of this cube or this rectangular box? You just multiply them together. Let's do it in our head. 3 times 4 is, 12 times 5 is 60. Is it 60 centimeters? No, it's 60 what? Centimeters cubed. Very good. It's centimeters cubed because centimeters times centimeters times centimeters, there's 3 of them. It's centimeters cubed. And that's pretty important, okay? The units for volume, area, perimeter, and all that stuff are very, very important. What are the units for area? We're going to do an area in a second, but just like a regular rectangle. Let's say you had a basic rectangle. Oh, why is it white? I don't know why, but that's all right. No big deal. So if this is the length and this is the width, how do we find the area of the rectangle? We did this yesterday. It's the length times the width. But let's put the units in here. Let's say it's meters this time just for fun. Just make it different. So what would it be? It would be meters times what? Meters, which is what? Meters squared. Okay, so area is always squared. What about the perimeter? I'll throw that over here. What about the perimeter? The perimeter is just the distance around. So if I wanted to add up, this is 2 centimeters, this is 3 centimeters, this is 2 and 3. If I added them up, what would I get? What are my units for perimeter? Is it squared? Is it cubed? Let's say it's in centimeters. What would it be? It's just centimeters. Very good. Okay, I'll just put that. So the units for perimeter is just in centimeters or meters or yards or inches or miles or whatever they tell you. All right, so it's just centimeters. Everybody got that? Perimeter should only be in the single units, okay? Meter, centimeter, kilometer, whatever. The area should always be squared, all right? The volume should always be cubed. If you can remember that, that'll help you out a little bit, all right? Now, here's another. We're going to stick with this box right here, but we're not going to do volume this time. Let's change colors to differentiate it. So let's do volume. Now, I'm sorry, not volume. We're going to do area, but we're not just going to call it area. What we're going to do is we're going to call it the surface area. You remember doing this in geometry? No? So what is the surface area? Again, if I was teaching this in geometry for the first time, I'd probably have a box up here, and I usually kept a box just for this. Matt, go ahead. Yeah, you could think of it that way. If you wanted to take this, cut it up, lay it out flat, yeah, it's the area of the whole thing. Or you could just think of it as the area of everything on the outside, okay? All the sides to this, all right? So what do you got? You got like a front, you got a back, you got a left side, you got a right side, you got a top, you got a bottom, okay? So if you wanted to, they're all rectangles, right? So if you wanted to, you could just figure out what the areas for both of those are. Well, tell me something about the front and the back. Like here's the front right here, and here's the back over here. What do you think's the same about them? They're just exactly the same, right? So there's two of them. So instead of going, so what would it be on this one? It would be length times what? The height, okay, for the front of it, okay? And the front and the back are the same thing, so it'd be length times height. Yeah, we'll do that. So the length times the height, that would be the front of it, but the back of it is exactly the same thing, so how many do you have? You got two of them, okay? So again, this is surface area. I'll just put SA for surface area. So you got two of them. Let's do the sides. Let's do the left, or the right side's kind of marked already. So what about the right side? You've got this, or this one right here. That's the width. And then if you want to find the area of it, what would you do? Find the height. So what's the side? What's the right side? The area of the right side of it. It would just be the width times the what? The height. Okay, so it would be the width times the height. But there's two of them. You got the right side and you got the left side. They're both exactly the same. So you put a 2. How do you find the area of those combined? Just add them up so far. Is that everything on this box? No. What else do we have? You got the top and the bottom, right? So you got the top up here. You got the bottom down here. Okay, let's just take a look at the bottom since we got these marked. So how do you find the area of the bottom? Well, it's the length times the what? The width. Okay, that's the area of the bottom. You follow me on that? And then we do the same exact thing. So we're going to put a plus because we're going to add that to our list. And then it's the length times the width. And how do you, you got top and bottom, so you got two of them. So there it is right there. So hopefully you don't try to just memorize this. Now, again, I told you I would give you the formulas. So I'll give you this thing. Here, let's do this. I know why that went white before. So I'm going to put this in a box right there. There we go. So that's another formula right there. Okay, so that's the surface area of a rectangular, what do we call it? Box, okay, or a cube, if you want to call it that. And there you go. That's not so hard, is it? I'm not going to put the numbers in just for the sake of time. It's pretty easy, right? Put the, like if it was this, I'd put the 3 in for the L, put the 5 in for the H, put the 4 in for the W, put them in, work them out, add them up, boom, you got an answer. All right, I'm not going to do that right now just because we got a lot of stuff to talk about today. So that is a rectangular box. Let's do another shape. Let's come over here. I got some more cool shapes. Well, I don't know how cool they are, but they're kind of cool. All right, so we got this. Let me make this just a tad bigger. Right there. All right, there we go. What do you think we call this thing? It's not just a circle. It's like a ball, like a basketball or soccer ball. What do you think you call it? Just a sphere. Yeah, we call this a sphere. So let's write that down. I can't spell. S-P-H-E-R-E. All right, this is a sphere. So it's like a ball, like a basketball, okay? Except it's perfectly round. There's no ridges. There's no indentations or anything like that. It's a perfect sphere. So we are going to learn two things for this. We are going to find the surface area. I'll just put SA now so you know what that is. We're going to find the surface area of a sphere, and we're going to find hold on. Yep, the volume of the sphere. So we're going to do surface area, we're going to do volume. I'm not going to talk about this. I'm just going to write them down, just show you the stuff, and then you'll be good to go with this. All right, so the surface, let's do the surface area first. That's a little easier. So it's this. It's 4 pi r squared. Well, do you recognize pi r squared? What is that? That's the area of a circle, okay? So basically, if you took a sphere, let's pretend it's a basketball, perfectly round ball, okay? And if you were to cut it up, you could actually take 4 of the circles. Do you see the circle that it makes kind of in the middle right here, that dotted line and this line right here? If you take 4 of those and cut them up a certain way, I don't know, it'd be pretty hard to do, but if you were able to do that, exactly 4 circles of this particular radius can wrap around the ball. All right, that's basically what it is. See the 4 pi r squared? So if you take the area of this circle right here, and then you just multiply it by 4, that's the whole surface area of the ball. So if you wanted to paint the ball or something like that, you want to find out how much paint you needed and how many square inches or square feet or whatever, that's how you could do it, all right? So something that's important about this is this right there. What is that? What's that dot right there? It's the what of the sphere? If I had a circle, what's the dot in the middle of a circle? It's the center of the circle. And I forgot to talk about that yesterday, but I kind of figured you might know that already. But it's the center of the circle. So if I take from the center to anywhere, okay, I don't have to go like just to the right of it. Well, I got all this stuff here. Let's get rid of that. Okay. That thing right there, what do you think that thing right there is, that yellow line? It's the radius, okay? Very similar to the circle, isn't it? Okay, so that's the radius of the circle. That's all you got to know. In order to find the surface area of the sphere, all you got to know is the radius. Sometimes they'll trick you up a little bit in the problems, and they'll give you the diameter. So if they give you the diameter, how do you find the radius if they give you the diameter? Just take half of it, right, divided by 2. Okay, that's pretty simple, right? We good with that? Surface area, so what are my units going to be in? My units are going to be square whatever, let's say meters. So it's going to be in, I'll just put it in parentheses. So the units are going to be in square meters, meters squared, okay? Volume, what are my units in volume for anything? It's always meters what? Cubed, right? Or inches or whatever it is, right? Now this one's a little bit confusing. And again, when I teach geometry, I go through the whole process and show you why it's this number. But for right now, just because it's time, is because it's review, I'm not going to do all that, but I'll just give it to you. And I don't like doing this. I like to explain where these formulas come from, but in this case, I'm going to just give it to you. So it's 4/3 pi r cubed. All right, so it's a little weird. Where in the world they come up with that 4/3? Well, look it up on YouTube, find it somewhere, okay? How do they come up with the volume of a cube? I'm sure you're not that interested, but if you are, they could show you how to do that. Again, in geometry, I do that. You could probably watch one of my geometry videos from Mr. Hammy's math class and look back and find out, because I probably explained it back then. But that's what it is right there. Again, the only thing you have to know about this sphere is the radius, right? Because you know what pi is. What's pi? Did we talk about pi the other day? 3.14, right. I don't even think I mentioned that, did I? I just kind of assumed that you knew what pi was. But pi, right there, is 3.14. Does it stop right there? Now, it keeps on going infinitely, but we're just going to use 3.14. If you have a calculator with the pi button, you could always just use that too. But it goes out a whole bunch more places. It goes out, like, I don't know, 7 places or something like that. I forget what it is. But you just do this. Put 4/3, okay, which is 1 1/3. All right, but you just put 4/3, or you could write it like this. You could write 4 pi r cubed over 3. If you want to write it like that, that might be a little easier for you instead of seeing a fraction. It's the same exact thing, isn't it? So you could write it like that. Again, I'm going to, I'll give this to you, and I'll give this to you right there, okay? So I'll give those to you. You just got to know how to use them. Pretty simple. If you know the radius, you can figure out these things. All right. We good with that? We got one more of these things, and then we'll do an example. And it's this thing right here. Copy that. Let's slide this up here like this. Oops, paste it. There we go. What's this thing called? Anybody know what that's called? Cylinder. It's a cylinder. So it's cylinder. Okay? And basically, there's only two things you need to know about the cylinder. One is the radius, because the bottom of and the top of it is a circle. Do you see that? And it goes straight up and down. The straight up and down, remember we talked about the triangle, the base and the height have to be perpendicular to each other? Remember we talked about that yesterday? It's the same thing with this. The height and the radius have to be perpendicular to each other. So that's pretty important. I don't think they do a slanted one, but in geometry we had one that was kind of slanted. And so you can't really do the slanted part of it. It's not the height. It's always from the top, perpendicular to the bottom. That's the height. All right. Right now we're just going to do a very simple one, and that's this right here. So let's do the volume and the surface area. I'm going to do volume first on this one because it's just a little bit easier, a little less stuff. So the volume is just pi r squared times the height. So what's pi r squared again? It's the circle, right, down here on the bottom. So basically, it's the area of this circle times how tall it is. You follow me on that? It's pretty easy, isn't it? So it's the area of the circle times how tall it is, right there. That's the volume. So that's one that I'll give you. And again, you're just plugging numbers in, so it's really not that big of a deal. But you just got to know what all these things are. So surface area. Let's do the surface area. This is a little bit more complicated, but again, let's take a look at the surface areas that we have. We got the bottom, we got the top. What kind of shape is the bottom and the top? It kind of looks oval here, but it's really not because it's supposed to look three-dimensional. What kind of shape is the bottom of the top of a cylinder? It's a circle. It's a perfect circle. Okay, so it's pi r squared. So that's the surface area of the bottom, but also the top. So there's two of them. They're both exactly the same, so what are we going to put out in front of it? A 2. You with me on that? So that's the surface area of the top and the bottom. Now, what about the other part, okay? A lot of times I'll do this. I'll take like a piece of paper. If you're watching this online, you won't be able to see this, but I got a piece of paper right here. That's kind of like a cylinder. Would you agree? All right. So what if I took the cylinder and I cut it, right up the edge right here? It turns into a what? It turns into a rectangle, doesn't it? Okay. And so if it turns into a rectangle, I'm not going to try to draw it, but what's the area of a rectangle? I'm so tempted to do this, but I'm not going to. I said I wasn't going to do it. But anyway, that's how you figure it out. So you could put it's pi r h. I'm sorry. Yes, that's correct. And then a 2 in front of it. I'm so tempted to show you how we got that. But again, I'm running out of time, so we got to make sure we get through this. So those are your two things. That's surface area, that's volume of a cylinder. Again, all you got to know is what the radius and the height of this thing is. And that's it. That's not too bad, is it? I got an example to do. I got some crazy thing. I just drew this a little earlier. Let's copy that. Let's go back to this. And this is actually the example in your book. All right. Let's make this just a little bit bigger. Right there. All right. And let's see, put some numbers on here. This is not exactly right. This center of the circle. Oops, I got to ungroup it, sorry. I think that, let's see, ungroup it. Let's see if I grabbed it. No, there we go, yeah. That center should actually be right there, but I couldn't draw it and get rid of all this stuff on the edges. So I tell you what, let's get rid of that part and let's just put a, I'll just try to draw it freehand. This is going to be ugly, but we'll try. So I don't know, maybe it goes up to here. Oh my goodness, it's going to be awful. So that's not terrible, all right? And I'll tell you what, I'm going to get rid of the fill on that. There we go. It looks like it wants to be all blue, so let's make it blue. All right, there we go. So that's what we're trying to find the, what do they ask you for? Just the area, okay? They just ask you for the area of this. It's not even a three-dimensional figure, so we probably could have done this yesterday. All right, so let's put some numbers in here that they tell you. They tell you that they put a dotted line here. Boom, 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 boom. All right, and they give you that, and they say that's 6. They put a little thing here. And that's important to know that they're perpendicular to each other. And they put a 4 right here. The 4 represents from this edge to this edge. You see that? And what are they asking? They're asking for the area. So they're saying, what is the area of this thing? Well, we don't have one formula for this whole thing because we got 2 different shapes, don't we? So what kind of shapes do we have? What's this thing with the 6? What shape is that? It's a triangle, okay? And what shape is this thing? It's supposed to be, okay? It's not perfect, but what do you think that is? Is it a full circle? It's a semicircle, okay? So basically, we just find the area of a full circle and do what to it? Divide it by half, or divide it by 2, not by half, but divide it by 2. Take half of it. Does it make sense? So really, it's just you're doing 2 things. Find the area of the triangle, find the area of the semicircle, and you're just adding them up. That's all you're doing. All right, so let's do the semicircle first. So I'm going to put SC for semicircle. All right. So a regular circle, a full circle is pi r squared. But what are we going to do to it since it's a semicircle? Just going to divide it by 2. So let's throw some numbers in. It's pi. Now we got to think about this. What's the radius? Is the radius 4? What is the radius? 2. That's right. It's 2. Because the diameter of this is 4, but the radius is 2. It's very important that you understand that. Don't just stick the number in there because you see a 4 there. Got to put a 2 there because it's half of this, right? Because it would go to here. The whole thing is 4. This little bit from here to here would be 2. I'm not even going to write it down. Andrew? You don't like that color? Is it too dark? Let's go yellow. How's that? Is that better? Okay. Is it all right if it just stays right there? All right. So what do we got to do here? What do we have to do to the radius? We've got to square it and then do what? Divide by 2. We can do this a little bit of this in our head. What's 2 squared? 4 divided by 2 is 2. So it's just 2 pi, isn't it? And you can put that in your calculator in a minute. All right. We'll do that in a second. So now what we're going to do is find the area of the triangle. Okay, so the area of this triangle. What is the area of a triangle? What's the formula? Do you remember? Base times height. Is it just base times height, though? It's 1/2 base times the height. Or I like to put divide by 2 when I'm actually doing the math. So I'll just put it divide by 2. But you're right. It could be a half in front of it. It's the same thing. So this triangle right here, how much is the base of that triangle? It's 4. That's right. Because this right here is the base of the triangle. That's the whole length of the triangle. Remember, the base and the height have to be perpendicular to each other. So this is the base, and the height is 6. It goes from here perpendicular to the base, so that's got to be the height. So I've got the base is 4, the height is 6, and then I got to divide by 2. Why am I dividing by 2? Because it's a triangle. So 6 times 4 is 24. Let's do it in our head. 24 divided by 2 is 12. So the area of the whole entire thing is 2 pi plus what? 12. And then you can throw that in your calculator. All right, throw it in the calculator and you get like 18.28. Actually, you could do that in your head. 2 times 3.14. What's, if I double 3.14, that's easy. What's that? 6.28. Okay, and then I add it to 12. 12 and 6 is 18. 18.28. Everybody see that? So they gave you really simple math and all that. So the area of that thing is 18.28. Do they tell you units? Let's say it's in centimeters. So if it's in centimeters, what are my units? Centimeters what? It's area squared. Area is always squared, okay? So it's 18.28 centimeters squared. All right, that was pretty easy, wasn't it? All right. Now, we're sticking with geometry, but we're going to do something a little bit different here. Let's see, when's this over? This is 50? Okay. Just make sure I keep an eye on the clock. You know what? I'm going to stop here. So I'm a little behind on I was right up to date until today. I thought I would finish today, but I think the stuff that we're going to do next is really completely different than what we just did. And there's quite a bit of it. So I thought I'll just save that for a whole class period, okay? Tomorrow's a shorter class period, but I think I can cram it into tomorrow, okay? So the homework assignment, though, that I gave you, I believe, 36, 37, there's still some stuff on the things we're going to talk about tomorrow, but if you go to it, I'll tell you what, I'll stop recording this. So, the stuff that I gave you yesterday, I'll just write it down just so if anybody watches this, they need to know. It's page 36, 37, and it's 11 to 43 odd. But you probably won't be able to do some of the ones on the end because that's the stuff we haven't talked about yet. But I'm going to shut this off, and we're going to look at the book and see where the new stuff starts, okay? All right, so we'll end it here.